Algebra 1, Unit 5, Lesson 2, Part 1, Special Linear Functions. We're going to cover horizontal and vertical lines and something called direct variation or proportional relationships. Some lines are special cases of what we covered, and one of those are horizontal and vertical lines. So a horizontal line is one which has only a y in it, and a vertical only has an x in the equation. A horizontal line y equals b will go this way because the y value for every point on a horizontal line is the same. For those lines, remember, there is no slope. B could be any number, and x will take on any particular value. A vertical line has the equation x equals a. Again, any point along a vertical line has the same x value. The slope of that is undefined because if we sat on it, we would slide right off. So it's so steep that the slope is undefined. A will be any number, and y can take on any value. Remember that horizontal lines are actually functions, and these are vertical lines are not, because they would fail the vertical line test. So this one says, graph the line or give the equation. If you have the graph, give the slope. Is the line horizontal or vertical? X equals 3 will be a vertical line because there's just a 3 or just an x value. And we have x equals 3 here, where every point along here has x equals 3. So that gives us this line, and the slope is undefined. Y equals minus 5, again, has just a y value, so that makes that a horizontal line. It goes through minus 5 as a y-intercept, and every other point along here has a y of minus 5 as well. The slope of such a line is 0. Here we have an equation. We see that this is a vertical line, so it's an x equal equation only. It goes through minus 8, so that's x is equal to minus 8, and the slope is undefined. We can also have lines that show direct variation. Direct variation is of the form y is equal to kx, and the b is 0. Since the b is 0, that means it has to have a y-intercept of 0, or it goes through the origin 0, 0. So direct variation is exactly that. It's a line that passes through the origin, and the slope is the number which we sometimes call k when we have direct variation. Because the y-intercept is 0, it means that this slope is simply, if we take the x to the other side, it's y over x for any pair. So if you give me a pair of points, I only need one pair when it's direct variation instead of the two that I normally need because I already know that b is 0. So I can simply take the y value for the pair and divide by the x value for that same pair, and that will give me the slope. And because of that, it has to be the same for any sets of pairs. We say that y varies directly with x, or y is proportional to x, and that slope k is called the constant of variation. One example of that is the distance is equal to the rate times the time, where the speed is the constant or the slope in that relationship between distance and time. So here it says, identify if each linear equation is one of direct variation or not, and graph. Here we have y equals minus 2/3 x. There's no constant added, so that is direct variation. The slope is minus 2/3. So we know it must go through the origin, and then we do just like before. The slope is minus 2/3, meaning we're going to go down 2 and right 3, down 2 and right 3, down 2 and right 3, or we can go up 2 and left 3, up 2 and left 3, up 2 and left 3. As long as we're going one in the positive direction and one in the negative, it will give us a minus 2/3. Y equals 3 halves x plus 4 will not be direct variation because there's that 4 that's added to it. The slope is 3 halves. The y-intercept is 4. This is just a general linear line. It goes through 4 as the y-intercept, and then they both either have to be positive or both negative to give a slope of 3 halves. So we can go up 3 and right 2, up 3 and right 2, or down 3 and left 2, down 3 and left 2, all the way to get those other points. Suppose y varies directly with x, and y equals 8 when x equals 3. So if we want to find the constant, we first have to take the y of the pair and divide by the x of the pair, so we would get 8/3. And then the equation of the line would be y is equal to that k times x. If we want to find the value of y when x equals 9, we put the 9 where the x is and solve that. That will give us 24, meaning we would have the point 9, 24 on the line. If it says y is 64, we then need to put that in where the y is 64 in that equation and solve. If we divide both sides by 8/3, we end up with 24, and that would mean the point 24, 64. Those would be two different points in the graph, along with the original point, 3, 8, which is also on the graph. We also want to be able to do this from words. It says the distance a flock of snow geese can migrate varies directly with the time they fly. A flock migrated 375 miles in 7.5 hours. So first of all, we know this is direct variation because it says varies directly. That also tells us what the y variable is and what the x variable is. Remember, y varies directly with x, so the one that comes before varies directly is the y, that's the distance, and then what comes after that is the x variable, so time is the x variable. But here we're going to use distance as d and time as t, the normal way of doing it. Instead of using k in this equation, we'll also use r because that's the known relationship. D is equal to r2. We could say d equals kt as well. So if we'd wanted to, we could have said d is equal to kt, understanding that k is the speed that the birds are flying on average. So d is equal to rt. From this, since the distance is the y variable, 375 miles, that's our d, that's our y variable, and then the hours, the time, is the x variable. So we have 375, the distance, is the rate, times the time, and if we solve for the rate, we get 50, meaning that they were going 50 miles an hour, and the distance is equal 50 times t. Now, if we want to graph the function, again, we can pick any scale we like, so I've decided to take the x is up by 2, and then put the y's up by 100 by taking 4 squares, meaning each square is 25. And we know that when x is 1, y is 50, or when the time is 1, d is 50. When the t is 2, y is 100, so that would be a point. If I put in 4 for the time, I get d is 200. Or once I've got some, I can see I'm going over 2 squares and up 4 squares, over 2 squares and up 4 squares, recognizing that means 2 hours but up 100. 2 hours and 100 because 100 over 2 is giving me that slope of 50. So I'm going up 100 and over 2, up 100 and over 2, up 100 and over 2, but in my scale I can simply count 4 squares. How long would it take them to migrate 3,000 miles? Again, that's a y value, so it has to go in terms of the distance. So I would put it on this side of the equation, 3,000 equals 50t, divide both sides by 50, and that gets t equals 60. So it would take 60 hours for the flock to migrate 3,000 miles.